Hi folks, welcome back. And I'm going to talk here a little bit about parallel circuits. We've got a parallel circuit set up for you on the FET simulation. Notice here I've got the values, 20 volts for the battery, 10 ohms for each of the lamps. That's because I clicked the values box off on the right side over here. If that helps you to do during the virtual lab, maybe you want to try doing that to see what the values are. I think some of you may have forgotten to make our battery 20 volts by clicking on it. So that might have caused some errors if you got some numbers that seemed a little bit off when doing the activity. I'm going to start here by closing our switch and watching what happens to the lamps. Do they light up at the same time or not? And as you notice, they do light up at the exact same time. That's kind of what we expected, like we talked about in the previous video. All of the electrons start flowing simultaneously in every one of the wires. So it's not like electricity starts at one place. It all is just a continuous flow. Now, if I open my switch for a second, we're going to bring out our voltmeter, and that's because we want to measure the voltage now across lamp 1, which is up here, and lamp 2 down here. I'll close my switch, and I'm going to put the probes of my voltmeter across either end of the lamp, and I'll notice that lamp 1 actually gets 20 volts of voltage. Now, some of you might find that strange. You might think that the two lamps need to split the voltage like they did in a series circuit, but that's not the case here. In fact, lamp 1 is going to get all 20 volts because it's basically connected on its own path with the battery. It doesn't need to share any of the voltage. Now, what's interesting is that if I disconnect this and then I put the probes across lamp 2, you'll notice that lamp 2 also gets 20 volts. That might seem strange. How can they each get 20 volts? But that's because they're both hooked up individually to the battery. In fact, if I hooked up more and more lamps, all of them in parallel, each subsequent lamp would each still get 20 volts from the battery. It's like they're just hooked up individually to the battery. Now, I'm going to bring out our ammeter to measure the current, and we're going to go back to lamp 1. And we're going to measure the current across lamp 1. But before I even put my ammeter over it, you might notice the voltage is 20 volts, the resistance is 10 ohms. Ohm's law says that V equals I times R. Voltage equals current times resistance. If I rearrange that equation, V divided by R equals I, voltage divided by resistance equals current. So here the voltage of 20 volts divided by the resistance of 10 ohms should give me the current of 2 amps, and that's exactly what we find using the ammeter. That's the same thing at our second lamp. If I find the voltage across it of 20 volts, I find the resistance is 10 ohms, and I do 20 volts divided by 10 ohms, I get 2 amps once again. So that's how we figure out the current using Ohm's law if we know the voltage and the resistance at a different place in the circuit. Now, I'm going to put the voltmeter away, but before we throw away our ammeter, let's look at the current near the switch. You'll notice that it's 4 amps, and that might be surprising to some people. They would say, wait, shouldn't it be 2 amps, so it's 2 amps everywhere in the circuit? But in fact, let's look at this junction right over here. At this junction, notice the electrons are coming in with a certain speed, but they leave with a faster speed. That's because we had 2 amps of current in this wire and 2 amps of current in this wire. So since there were 2 amps coming from 2 directions, they combine to make 4 amps when it eventually passes through the switch. And I just opened my switch, but we should get 4 amps as you're seeing over here. So that's why the currents are actually combining in the parallel circuit to be larger when it comes back to the battery. Let's put away the ammeter, and we'll wrap up with one last question. What happens if I was to disconnect one of the lamps? Let me disconnect lamp 1 and say that it burns out. Notice lamp 2 stays on with the exact same brightness. That's because it's still connected to the same battery and still getting 20 volts with 10 ohms of resistance. We haven't changed anything by hooking up or disconnecting the first lamp. If I reconnect it, notice nothing changed with my other lamp. Now if I disconnect lamp 2, notice the same thing happening with lamp 1. It stays on at the same brightness because once again, it's still individually connected to the battery and it's still getting the full 20 volts. So hopefully that was a good summary for you about parallel circuits. They're a little bit different than series circuits, but hopefully you keep those differences in mind as we go forward. Check your work on parallel circuits and see how your work compares to what you just saw.